Hi folks, Chris McClure. We are now going to transition to solving quadratic equations. Last time we were talking about solving linear equations. And before we get started here, I just wanted to reiterate that when we are looking to solve an equation, what we're trying to do is we're trying to solve, or rather find possible value or values for the variable, typically x or t or whatever, such that that value or those values of that variable will make the equation a true statement. Now, it's possible that there could be one solution, multiple solutions. In fact, it's entirely possible that all possible real numbers will be the set of all solutions. Or it could be possible that there's no solution. When you go through the solution process, maybe you'll come up with an impossible equation as one of your equivalent equations. Or you'll come up with a number that when you go and plug that back into the original equation, you'll see that the equation is not true, or there's some expression that's not defined. So I will caution you to double check any numbers that come up as possible solutions. Okay, now we're going to press forward talking about solving equations in this form right here, where you have a second degree polynomial on the one side and 0 on the other side, where a, b, and c are real numbers. And, of course, the leading coefficient, a, is not 0. Because if a were 0, then we would just have a linear equation, which we already have talked about. So we're going to look at some different ways. The first method is to solve the equation by factoring. So you move all of the terms in the equation over to the left-hand side, and you have a 0 on the other side. And then you factor that polynomial on the left-hand side. In this case, you have x squared minus 4x equals 0. You factor x squared minus 4x as x times x minus 4. And using the zero factor property, you see that either x is equal to 0 or x minus 4 equals 0. And if x minus 4 equals 0, that means x equals 4. So you have two possible solutions. And by inspection, you can tell that if x is 0, the right-hand side is 0. Or that both sides of the equation will be equal to 0. And if you were to plug in 4 for x, you'd have 16 minus 16 is 0. And that's also a true statement. So both of these numbers really are solutions. They make up the solution set for this equation. So it's always a good idea to check these numbers that arise from the solution process to verify that they really do form the solution set. And oh yeah, by the way, it's appropriate for us to use the opening and closing curly braces to indicate that, hey, we've got a set of numbers which satisfy the equation. That's why they call it a solution set. All right, here's another example here. We have x squared is equal to 6 minus x. Move everything over to the left-hand side by adding x and subtracting 6. And then factor that polynomial on the left-hand side as x plus 3 times x minus 2. And that means that x is either equal to negative 3 or x is equal to 2. And again, verify these numbers one at a time by plugging them in for x into the original equation and verifying that the original equation is true. In the case of negative 3 squared is 9. 6 minus negative 3 is also 9. Okay, so negative 3 really is a solution. Plug in 2 for x. 2 squared is 4, and 6 minus 2 is 4. So indeed, both of these numbers, negative 3 and positive 2, are solutions to this second order equation. Now, what we could also do is, if you have an equation of the form x squared is equal to some number, p in this case, then that means x is either equal to plus or minus square root of p. So, for example, if x squared is equal to 7, that means what? That x is equal to plus or minus square root of 7. If x plus 3 squared is equal to 9, that means that x plus 3 is equal to plus or minus square root of 9. That means then that x, oh, by the way, square root of 9 is 3, so you have x plus 3 is equal to plus or minus 3. Subtract 3 from both sides. Now, if you have 3 on the right side, then that means x is equal to 0. If you had negative 3 on the right-hand side, then subtract 3, you have x is negative 6. So you have two solutions. Again, double check these solutions by plugging in 0 for x and negative 6 for x, and verify in both cases the equation is true. So 0 and negative 6 form the solution set as well. All right, moving along here. Now, we know how to complete the square, right? It's a very valuable skill. Suppose that we have this quadratic equation here. What we'll do here is we'll move that 5 over to the right-hand side by addition, divide both sides by 2, and then we'll have x squared plus 6x, x squared plus 3x, and then take half of 3, which is 3 halves, and take 3 halves squared, which is 9/4, and add 9/4 to both sides. That's what you'll need to add in order to complete the square. And then, of course, the left-hand side is x plus 3 halves squared, and on the right-hand side, you got 5 halves plus 9/4. Now, 5 halves is 10/4. 10 plus 9 is 19, so you'll have this equation here. Then that means that x plus 3 halves is equal to plus or minus square root of 19/4, which you could write as plus or minus square root of 19 over 2, because square root of 4 is 2, right? And then subtract 3 halves from both sides. So now you've got two solutions. You either have positive square root of 19 minus 3 over 2, or you got negative square root of 19 minus 3 over 2. So here's your two solutions, exact. Okay, so we just solve this equation by completing the square. Any questions? Moving along here, using the quadratic formula. Here's the quadratic formula that says if you have an equation of the form ax squared plus bx plus c equals 0, then x is going to be given by this formula right here, provided that b squared minus 4ac is not negative. If b squared minus 4ac is 0, then you'll just have negative b over 2a as your one solution. If b squared minus 4ac is positive, then you'll have two distinct solutions. Negative b plus square root of b squared minus 4ac over 2a, and negative b minus square root of b squared minus 4ac over 2a. All right, so let's take a look at our first example here. Suppose that we have 2x squared minus 4x plus 1 equals 0. Identify a as 2, b as negative 4, and c is equal to 1. And go ahead and plug those numbers into that discriminant b squared minus 4ac. Remember, b is negative 4, a is 2, c is 1. So that means that b squared minus 4ac is equal to 8, which is a positive number. So that means that we are going to have two distinct solutions. So we will go ahead and take the negative of negative 4, that's our negative b here, and of course that gives us positive 4, plus or minus square root of 8 over 2a, but a is 2, so over 4. So here's our two solutions here. By the way, square root of 8 is 2 root 2, so you can cancel a factor of 2 between the numerator and denominator. So you'll have 2 plus root 2 over 2, and 2 minus root 2 over 2 as your two solutions. Okay? Here's another example here. Notice that we have a fraction as our leading coefficient, but if you have a fraction as any coefficient, go ahead and multiply through by some number to neutralize any fractions. In this case, multiply through by 2, meaning multiply both sides of the equation by 2, which leads you to this one, and then identify A as 1, B as negative 12, and C as 36. And note that, by the way, that the discriminant works out to be 0 in this case, in which case x will just be your negative b over 2a, which is going to be 12 over 2, which is 6. There's only one solution in this case. Okay? Here's another example. 2x squared plus 3 equals 2x. Move that 2x over to the other side by subtraction, and then identify A as 2, B as negative 2, C as 3. Take a look at the discriminant. Works out to be a negative number, which means that there are no real solutions to this quadratic equation. Okay? Here's another example. You could multiply both sides of this equation by x squared, which gives you this equation, and identify the discriminant as a positive number, which means that you have two real solutions, and go ahead and use your quadratic formula to identify those two distinct real values, taking the plus and the minus. So there's your two solutions there, 1/2 and negative 2/3. So here's kind of a recipe and a reminder of how to solve quadratic equations using the quadratic formula. Identify your A, B, and C coefficients. Determine whether your discriminant is negative, 0, or positive. If it's negative, there are no solutions that are real. If the discriminant is 0, that means you have one real solution, negative b over 2a. And if the discriminant is positive, that means that you will have two real distinct solutions. Now, let's take a look at an application problem. Now, suppose that we have a piece of metal and it's square, but we want to have the dimensions of the square piece of metal so that when we cut out these corners, 9 centimeters by 9 centimeters, in the four corners like you see here, cut out these yellow squares right here, then we could use the blue piece of metal, bend those blue pieces at each of these, along each of these adjacent corners here, so that it forms a box. Now, let's suppose that the length of each side of the big square is x, as in x centimeters. We want to know, what is x? What is the length of each side of this big square? Now, we know that each of these corners are 9 by 9 centimeters. So that means that the width of each of these blue pieces here is going to be whatever x minus 9 minus 9. In other words, x minus 18. Here's a picture of our square. That's going to result by trimming off those 4 yellow corners and bending up the sides along here, 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 and here. Now you have this open top box right here. See, this top part right here is open. The volume of this box then is going to be 9 times x minus 18 times x minus 18. I know this kind of looks more rectangular than square, but I promise you that this really is a square. You might not look like it, but it's a square with these. Well, the base is a square. The vertical piece is 9 centimeters. So the question is, what does x have to be so that the volume is equal to 144 cubic centimeters? So what we'll do is we'll set 9 times x minus 18 squared to be equal to 144. And then go through and divide by 9. And then you have x minus 18 is equal to plus or minus the square root of 16, meaning plus or minus 4. Then add 18 to both sides. Now you have 18 plus 4 and 18 minus 4. So that means that x is either 22 or 14. Now, you look at this equation or even this equation, does it make sense for x to be equal to 14? And the answer is no, because we need for x to be no smaller than the 9 plus 9, which is 18. So we need for x to be not less than 18. So we can actually eliminate 14 as a potential solution. And that leaves 22 as our solution. And it makes sense to have x to be greater than 18. So we'll take 22 as our solution, meaning you want the length of each side of this big square to be 22 centimeters. Okay? So that is it for today's lecture. If you look on Blackboard, you'll notice that I have loaded up the rest of the PowerPoints for the course, now all the way through the end of chapter 6. Now, I don't know where exactly we will end up with the course. In the past, I've gotten through the end of chapter 6, but if we, for some reason, get through this material more quickly than I have in the previous semesters, then I will load up material from later chapters of the same textbook, okay? So that's it for today, and talk with you tomorrow, Wednesday. Bye.